Hi, budding geniuses! Ready to discover the incredible world of electricity? Today, we're going to meet the superheroes who work together to turn on your lamps and make your toys work. We will learn to recognize the elements of an electrical circuit and, above all, what they are used for. Let's go! An electrical circuit. What is it? Imagine you want to turn on a light bulb. You need several important things that work as a team. This is called an electrical circuit. But who are the members of this team? Let's discover them. Here comes the first superhero, the battery. It is also called a generator. What is his superheroic role? The battery is the power source of the circuit. It provides electrical energy, much like the engine in a car that provides the strength to move forward. No battery, no power, no light. It has two terminals, where its journey begins. A plus terminal, plus, and a good, minus, terminal. Great! Now that you have discovered the role of the battery in our circuit, are you ready for a little challenge? Let's see if you understood how it helps the light bulb to light up. What is the main role of the battery in an electrical circuit? A. Decorate. B. Providing energy. C. Switch on directly. So did you make your choice? Let's see if you got the right answer. And yes, if you have chosen option B, you are in good shape. Congratulations! Indeed, for something to work, you need energy. And in our circuit, it is the battery that plays this essential role. That's why the correct answer was option B. The battery is used to provide energy so that electricity can flow. Without it, there is no light. Now, how does that energy travel? Thanks to our second superheroes. These are the conductors, most often electrical wires. What is the superheroic role of the common threads? Conductive wires are like highways for electricity. They allow energy, electrical current, to move easily from the battery to the bulb and back to the battery. Electrical conductors are often made of metal, such as copper, on the inside, because metals love to let electricity through. Now, how do you turn the light on or off at will? That is the role of the switch. What is the superheroic role of the switch? The switch is like a bridge for electricity. When the switch is open, the bridge is raised. The power can no longer pass, the circuit is cut off. Result: the light bulb is off. When the switch is closed, the bridge is down. The power can pass, the circuit is complete. Result: the light bulb comes on. It therefore allows us to control the flow of current. Take a good look at this switch. It is currently in the open position, which means the light bulb is off. But watch what happens when I close it. There you go. The switch is now in the closed position, and as you can see, the light bulb is on. Power can flow. And if I open it again, the switch returns to the open position and the bulb goes out. The power is off. Do you see how a simple switch can control the flow of electricity? And finally, the one we were all waiting for, the lamp. It is also called a receiver. What is his superheroic role? The lamp is the device that uses electrical energy to do something. In this case, it transforms electrical energy into light and some heat. It is thanks to her that we know if our circuit is working. Other receivers may be a running motor, for example the electric motor shown in this image, or the motors of a robotic arm, shown in this image. For the light bulb to turn on, the path for electricity must be complete and uninterrupted. This is what we call a closed circuit. All the elements must be well connected, from the terminal on the battery, through the wires, the switch closed, the bulb, and go back to the plus terminal on the battery. If the path is cut somewhere, for example, if the switch is open or if a wire is unplugged, the circuit is said to be open. The electricity can no longer circulate and the light bulb stays off. And that's it. Now you know the main elements of an electrical circuit and their super important roles. The battery, generator, provides energy. Conductive wires transport energy. Insulators protect and prevent energy leaks. The switch controls the flow of energy, opens or closes the circuit. The lamp, receiver, uses energy to produce light. And finally, remember, for it to work, the circuit must be clear.
Congratulations! You are now an expert in electrical circuits. See you soon for new scientific adventures.